1 plus
1 0
1 0.
then asterisk.
0 plus 1 0.
One time I have used 1 0, another time I used 0 1, so two are combined.
0 1 plus 0 1 plus
Only
1.
1.
0 1 plus 1.
0 1
Plus 1. Plus 1. Plain word.
Inclusion. Right? But how I write this? This is also acceptable, isn't it? Here there is no condition of beginning with 1.
Plus 0.
So small extension of it is so in this part we have represented the strings that are starting with 1. So this has covered the strings may start with 0 as well. This epsilon is representing this part, but 0 is representing beginning with 0. So next regular expression, write down the regular expression that denotes all strings of zeros and ones ending in 0 1 1. Ending in 0 1 1. One one.
0 plus 1.
0 plus 1.
0 plus 1.
0 plus 1 asterisk.
Then 0
0
1
1
1.
1.
ठीक है? Next, write the regular expression that denotes any number of zeros followed by any number of ones followed by any number of twos. We have already done in finite automata with epsilon moves. Now we are representing in a regular expression any number of zeros followed by any number of ones followed by any number of twos.
0 asterisk plus 1 asterisk plus 2 asterisk.
Is it right?
Sir,
Not plus.
epsilon use करा.
Concatenation operator. Next, write down the regular expression that denotes strings of zeros, ones and twos in which any number of zeros followed by any number of ones followed by any number of twos, but with a condition with at least one of each symbol. With at least one of each symbol. At least one each symbol. So we are replacing a static with plus. Clear? So we are clear about how to write the regular expressions. So rest depends upon the practice. So now we come to how to convert the regular expression into finite automata. Then we will be done with the section B. So if the regular expression is epsilon, how to convert this regular expression epsilon into the finite automata? So this is how it will be represented. Then if the regular expression is 5, how to represent it? Then next, any input symbol. Is it right? Is it clear? So just one symbol is there that is accepted, and what is the set that is accepted, that is represented by this regular expression? What is the set? That is set of strings. E1. Clear? So then we are going to represent R plus S, and indirectly what we say that R union S. So suppose there is one finite automata denoted by capital M1 that is accepting the set of strings of R. M2 is the finite automata representing the set of strings accepted by capital S. Then we have to union these, right? So we draw it like this. In the case of finite automata M1, we start with its initial state and we are reaching at its some final state. We are not considering about the intermediate part, right? Similarly, this is for R, and similarly for S. Right? Now what is our objective? To accept both of the strings, either this or this. What we'll do is, we will add one initial state, we can go to this or we can go to this. Either we can move to this path or this path depending upon the string, input string is accepted by M1 or M2. If it is represented by M1, we will follow this path, otherwise we will follow the M2 path. And then from here, we have the common finite state. If it is acceptable by M1, then it is acceptable by R union S also. If it is accepted by M2, this is accepted by R union S as well. Right? So this abstraction has been added and this becomes the finite automata for R union S. Clear about it? Now then we move to RS. So similarly, we have R finite automata corresponding to R, finite corresponding to S also. But here the thing is, from QF of M1, we are taking a epsilon move to the initial state of S. Right? See, this is for R, this is for S, Here we have M1. Similarly, QF1, Q01. Here Q02, M2, and QF2. Right? So now, this becomes the initial state of the whole RS, and this becomes the final state of whole RS, right? And from here to here, we will take a absolute. Is this thing clear? Now, next is R static. So it means 0 or more times repetition of same thing 0 or more times. So corresponding to R, we are having the same thing. So now how it is working? If it is repetition 0 times, so it will go directly from here to here, right? Repetition of same thing again and again, so this will be solving this problem. What we are doing is, hypothetically we have added these two components in front of this actual R or M. So we have taken epsilon move, we moved over here, right? And we have processed it again and again as many times as we have. Suppose we are talking about A only. So we reached here. Here is a move for A, suppose. Right? So one time we have processed A, then we have second time again we have A. So we have come again over here. And we go on processing A as many times as we have. When we have processed all, then we take an epsilon move and release to QF. Right? So that part will be looped over here. So any doubt in these? Then we'll go for one example. Just take a look and then let me know if there is a problem. Otherwise, we'll go for example. Move to example. Here. Corresponding to R, we have M1. Corresponding to S, we have M2. Concatenation means the strings accepted by M1 will be concatenated after the strings accepted by the M2. So both individually cannot work, right? So if I say R is representing A and S is representing B, RS will be representing AB. So I write Q node A Q1. This is for, here I write Q node 1 B QF. Here I take epsilon move. So A, B will be accepted. So this becomes the initial and this becomes the final. Right? Any more doubts? So this is the regular expression given to us, and we are converting into finite automata. So first of all, this seems to be the symbol of union. So this, if we say this is R and this is S, so what we start with, we start with the initial state Q node, then we take epsilon move, we go to Q1, we process 0 1 star, here we take the epsilon move, here we go to Q2, we process 1 over here, we reach to Q3, Q4, and then we move to. Is it clear? Epsilon moves. Is this thing clear? Now, do we need to explore this part? No, because it is already explored. There is no concatenation, no asterisk, anything. We need to explore this now. So what we do is, this portion has been explored to this. Clear? Do we need to explore it more? So this needs to be explored first. And this is for enclosure. We've explored सारा कुछ. So this has been first explored to this part. This need not to be explored, so we need to explore this part only. Right? So now how we'll write it complete. So just have a look on it. We start with Q node, then epsilon move is there and epsilon move is there. Right? Then we have Q1, then we have the 0, then we have Q6, then this epsilon, Q5, 1, Q4, epsilon, Q7, right? So this is epsilon, this is epsilon. This is done. Now from here we have epsilon and we have reached to final state. Now this part we have moved to Q2, 1, Q3,
So you want this type of
one asterisk. So you forget this asterisk first. So for only one, we have only Q5, 1, Q4, right? So if 1 is there, so 1 has been processed over there. Again we have to start processing from here. From here to here we have to take them 7 move to come again at the starting point. Again